Today, I'm going to walk you through the exciting new features in SoundCheck 21. SoundCheck 21 introduces our new algorithm for transient distortion measurement and detection, enhanced loose particles. We've added even more multi-channel measurement capability with the new Multichannel FFT spectrum analyzer. Sequence data can now be documented and stored in a whole new way with metadata, and sequences can be secured safely with sequence protection. And finally, SoundCheck 21 supports our brand new, compact, and high-resolution audio interface, AudioConnect 2. Let's kick things off with our newest algorithmic advancement, enhanced loose particles. SoundCheck's new enhanced loose particle algorithm measures transient distortion independently of harmonic or rub and buzz distortion. This new algorithm builds on the success of our original 2005 algorithm and introduces advanced techniques to better highlight the loose particle defects while minimizing other artifacts. This makes it easy to set limits in line with subjective tests. In addition to identifying distortion caused by foreign material in the voice coil gap of the speaker, it is also valuable for detecting rattling parts on smart devices and Bluetooth speakers, and identifying buzz, squeak, and rattle in automotive applications. Let's look at how our new enhanced loose particle algorithm analyzes a good speaker and a speaker with transient distortion. This one's the good speaker. You can see a nice, smooth response waveform. And here's the speaker with transient distortion. This actually has a loose solder bead trapped inside the voice coil gap. You can see these little glitches on the waveform. That's the rattling solder bead. First, we remove the fundamental, leaving just the distortion artifacts. And we can play this through SoundCheck to listen to the recorded artifacts and correlate what you hear to the measured results. Here's the good speaker. And here's the bad speaker. This really helps us understand how the measurement relates to what we hear and helps set limits. Next, we apply an envelope analysis to get a time domain measurement. You can see the energy in the recorded waveform plotted against time. You can see the transient defects as random bursts of energy. You don't see these on the good speaker. Now we calculate the prominence of the energy bursts, or the magnitude of the peak relative to the adjacent minimums. This methodology was the result of extensive research at Listen, where we determined that the prominence of a peak reflects the impulsiveness of the distortion artifacts more accurately than the absolute magnitude of the peaks. We then set a threshold, and if the prominence is above this threshold, it's counted as a transient artifact. And to help determine the threshold at which you can hear the distortion, you can play back the filtered artifact waveform to correlate the prominence level with audibility. Lastly, we count the number of events that exceed the threshold over the measurement duration, and we can set a pass-fail limit based on this number. This gives us reliable results under a variety of conditions, because in a typical production measurement, background noises like air compressors going off or pallets being dropped in a warehouse typically only occur once or twice compared to many loose particle transients. So as long as you set the limit according to your environment, you can always get reliable results. So that's it. This new algorithm accurately and reliably detects transient distortion and analyzes it separately from harmonic and rub and buzz distortion. It's accurate even with background noise, easy to correlate to audibility, and even easier to set limits. Our new multi-channel, real-time FFT spectrum analyzer lets you view multiple live FFT spectra simultaneously on the same graph. It offers the same high-resolution constant bandwidth filters as our original single-channel spectrum analyzer, so it's ideal for viewing narrow frequency components such as pure tones and harmonics. Like the multi-channel RTA that we introduced back in SoundCheck 19, the multi-channel FFT supports any number of channels, only limited by the physical test interface you're using. Similarly, each channel can be configured independently, so you can process each individual channel exactly how you need. It also provides real-time calculations such as channel subtraction, maximum, minimum, average, and power calculations, displaying these results in real time. You can also display the harmonics on the FFT. This saves screen space and allows direct comparison when making multiple FFT measurements. Here, you can see I'm showing the power average of the two input channels. SoundCheck's FFT and RTA can be viewed simultaneously, either side by side or superimposed on one another in a single multi-instrument. This enables both high-resolution spectra and constant percentage bandwidth resolutions, like 1/12 octave measurements, to be viewed at the same time. This could be used for applications such as analyzing broadband speech signals while accurately identifying single-frequency interference tones, or analyzing intermodulation distortion in the presence of speech or music. You can also drag and drop the curves from the multi-channel instrument into another graph, or drag a static curve from another graph into the FFT or RTA to use as a reference. This has many applications, such as comparison to a headphone target curve, active noise cancellation, or automotive tuning applications. SoundCheck's new metadata feature simplifies data collection and documentation in both R&D and production applications. Curves, values, results, and waveforms can now be saved to a single TDMS file, along with all the test parameters acquired during the sequence run. Metadata can include system data such as sequence name, date and time, and SoundCheck license number. User-defined fields such as temperature, humidity, microphone distance, and of course, any test data available in the memory list, such as results, waveforms, and more. Both standard and custom fields can be saved, and you can even use a message step in a sequence to collect user input, which is also saved in the metadata file. For example, you might ask the user to manually enter the subjective sound quality of the product under test, or what modifications were made to that particular prototype. The TDMS format that SoundCheck uses for saving metadata is National Instruments Fast Binary Format, which minimizes read and write times when a sequence is running. The TDMS data can be viewed or recalled in SoundCheck and also opened in other applications such as Microsoft Excel and MATLAB using a plugin. Our new sequence protection feature lets you lock and password protect your sequences. This is useful to guarantee your test integrity if you share test sequences with your contract manufacturers, or even if you just want to be sure your colleagues can't alter your sequences. When you lock and password protect a sequence, the sequence can be run but cannot be modified. Sequence steps and limits can't be changed, and even more importantly, can't even be viewed. This protects the intellectual property in your sequences, as well as preventing unauthorized changes. If you're sharing your test sequences with third parties, like contract manufacturers, you can be confident that your tests are only used on your products and can't be modified and repurposed to be used on other product lines. You can even go one step further and configure a sequence to only run on a particular SoundCheck system or group of system hardware keys. This is also simple to configure. All you need to do is enter the hardware laser ID displayed in the main SoundCheck screen, or import them from a CSV file. Locking a sequence to your particular system adds another layer of security and gives you 100% confidence that your measurements are being made on a genuine SoundCheck system with all the capabilities needed to successfully run the sequence. And just a final word of caution, all sequence protection data is encrypted, so make sure you have that password in a safe place, as even we cannot unlock your sequences for you. SoundCheck 21 supports AudioConnect 2, Listen's newest audio interface. This compact and fully featured audio interface and microphone power supply is the first that can be powered via a laptop's USB-C port. This makes it perfect for measurements out in the field, for example, in-car measurements or analyzing headphone noise cancellation in real-world situations. With sample rates up to 192 kHz and power for SCM and IEPE microphones, it's ideal for high-resolution measurements with most microphones, head and torso simulators, and test heads. It also has 2 output channels, a high-quality headphone amplifier, and more. But it's the integration with SoundCheck that really makes it powerful. Like the multi-channel AudioConnect 621, it has no buttons on the front panel to avoid accidental adjustment. Everything is controlled by the software. This can be done either within a sequence or through a software control panel. It also offers full plug-and-play functionality. There's just one USB-C cable to the computer for both power and data transfer. AudioConnect 2 is fully calibrated before it leaves the factory, and the calibration data is stored on the device firmware. When the AudioConnect 2 is connected to SoundCheck, everything automatically configures and self-calibrates, so there's no need for manual calibration. The input channels are automatically populated with sampling rate, and there's no additional cabling required for the device self-test, as all switching is internal. It also has TED support to automatically identify and read calibration data from TED's microphones and accelerometers. All of this makes for an extremely fast setup, whether you're configuring many production lines or constantly disconnecting and reconnecting a portable test system. In fact, the combination of AudioConnect 2 with its full software control, combined with the new sequence protection functionality, makes this a great production line test setup to ensure test integrity right through to the end of the production line. Thanks for watching this walkthrough of all the new exciting features in SoundCheck 21. If you're interested in learning more or getting access to these features, check out our website or email sales@listeninc.com.